All right, today is a really big day where we get to finally, I know you've been waiting for it, learn how to graph sine and cosine waves. So what we start off doing is going over our main angles that we remember. 0, we'll just do them in degrees. 90, 180, 270, also 360. And going over those ordered pairs, right? 1, 0, 0, 1, negative 1, 0, 0, negative 1. And we know for each ordered pair, the x is the cos, the y is the sine. The x is the cos, the y is the sine. The x is the cos, sine, cos, and sine. We know this, right? And I'm looking at my chart. The chart is in radians, so we might as well remind ourselves that this is 0 and 2 pi. Of course, 180 is pi, 90 is pi over 2, and 3 pi over 2. So when we fill in our chart and we say, what is the sine of a 0-degree angle? That's the y-coordinate, which is 0. Sine of a 90 is 1. Sine of a 180 is 0. Sine of a 270 is negative 1. And then the sine of a 360, of course, is 0. So if we take this sine wave and we notice that the axis is a little bit different. We're using quadrants 1 and 4. We've changed the y-axis to just go to 1 and negative 1. And we've changed our x-axis to count by our main angles of 90, 180, 270, 360. But moving forward, that x-axis will always be in radians. If I plot those points, the sine of a 0-degree angle is 0, the sine of a 90 is 1, the sine of a 180 is 0, the sine of a 270 is negative 1, and the sine of 360 is back to 0. And I connect my dots, I'm going to see this soft sine wave. Right? This is what we call a periodic function. If we were to keep continuing with that graph, going basically around the circle again, we would see this wave repeat itself over and over again. The two main things that we talk about for each graph, well, really more, because we always talk about the domain and the range, right? So the domain is all real numbers, and the range is from negative 1 to 1. So the domain is all real numbers, the range goes from negative 1 to 1. These two words, amplitude and period, are new to us. So we'll just like squeeze in a little definition here. The amplitude is the height off the x-axis of the wave, and I'm just using that in quotes, height off the x-axis. And the period is, I say, the time it takes to do the wave. The height off the x-axis, the time it takes to do the wave. So if I go back here and I think about how high this is off the x-axis, it goes up 1. And similarly, it goes down 1. The amplitude is here is 1. And it's worth noting that amplitude is always positive. Height is always positive. The period is the time it takes to do the wave. So if the wave starts here and the wave goes up and the wave goes down and then the wave finishes here, 2 pi is the period, the amount of time it takes to do the wave. Voila, the sine curve. The cosine is going to be real similar, but now we're taking the x-coordinates, right? So the cosine of a 0-degree angle is 1. The cosine of a 90 is 0. Cosine of a 180 is negative 1. And then 270, of course, 0 and 1. So we still have zeros and ones, but they're just a little bit different order. If we go graph these here, the cosine of a 0-degree angle is 1. Cosine of a 90 is 0. Cosine of a 180 is negative 1, 0, and 1. And this wave actually is kind of starting down and then coming here and then going back up. And then I put arrows on that wave as well because that is another periodic function that repeats itself. If I do the domain and range, domain is all real numbers. The range is between negative 1 and 1. So the domain is all real numbers. Range is between negative 1 and 1. And then the amplitude, just like the sine wave, is 1, and the period is 2 pi, the cosine wave. Now, our smart calculators know these answers. So if I turn on my calculator, I'm going to go to y equals, clear out whatever was in there, and I'm going to type in y equals the sine of x. Now, if I just did this on a regular xy axis, if I just did it on a regular xy axis and tried to graph it, it's not going to work. Right? That doesn't really look like what we just graphed. So I have to change my zoom to a special zoom. You might guess it. We're going to go down to zoom 7, which is Z trig. And there is the sine wave. Ta-da! And you could see there that it keeps on going, right? What we had graphed earlier was just one period of the sine wave, this piece of it. But you can see that it keeps repeating every 2 pi, every 2 pi, every 2 pi. If I also graph on the same graph, I can go down here and graph cosine x. I'll do it in a different color, but you'll get to see how those two graphs are related to each other. So the blue graph was my sine wave, the red graph is the cosine wave. The cosine wave is really just the sine wave shifted over, right? It's still periodic, it still has an amplitude of 1 and a period of 2 pi, but that is the cosine wave. Okay. So just to review, this is the basics of the sine wave and the cosine wave. Okay. But we are going to take it one step further. So here we're going to talk about, well, what would happen if we changed some things? So we talked about the words amplitude and period. We're going to start off saying, well, what if we changed the number in front? Instead of just sine x or cosine x, now we put a number in front. Call it 2 sine x or 1/2 sine x. And just like we've done with other graphs, we're going to use our calculator to help us see these patterns. So I'm going to keep my main sine wave, and then I'm going to add 2 sine x. So we'll take the cosine off for now, and if I graph them, I can see my sine wave going between 1 and -1. And then there is that 2 sine x, 2 sine x. And you might have noticed that it's just twice as tall. So I'm taking basically every y coordinate and doubling it. Now in the beginning here, I'm doing what I call the tick marks for you. I'm writing in on the x-axis the pi over 2, pi, 3 pi over 2, and 2 pi. Eventually we'll do those for ourselves, but starting off, we're doing it for you. What did I write? Amplitude of 1. Amplitude is 2. It's twice as tall. What do you think the amplitude is going to be here? 1/2 sine x. I bet you know, but we'll look at it anyway. Y equals, typing in 1/2 is just a little bit easier if I just do 0.5 sine x. So 0.5 sine x, graphing that. Yep, amplitude is 1/2. Right, 1/2. So, and you can see we've got the 1/2 there. It always starts at 0, 0. Make sure when you connect your dots that it's a real soft wave, right? It's not a zigzag, but it's a soft wave, amplitude of 1/2, period 2 pi. Now we've got a negative in front. Well, we've done a lot of things with negatives in front during the year. You probably remember that a negative in front reflects the graph over the x-axis, and this is no different. So if I have all those on there, it's going to graph them again. So there's the 2 sine x. There's the 1/2 sine x. And then here is the reflection, the negative sine x. It's going to take my sine wave and basically reflect it over the x-axis. So 0, 0 is going to stay. 0, 1 comes down to 0, -1, and 0, -1 goes up to 0, 1. This sine wave, even though it starts down, still has an amplitude of +1 and a period of 2 pi. Once we've done that and we kind of got that under our belt, I bet you're going to be okay here with the cosine wave. So remember, the cosine wave previously started at 0, 1, but if I'm going to multiply it by 3, that one is going to get 3 times as tall. And you could verify that one on the calculator too, but you would see that it has an amplitude of 3, period of 2 pi. Here, if I have 1/2 cosine x, it's going to have an amplitude of 1/2. And I'm following that pattern of a cosine wave, starting on the y-axis and then kind of looping down and back up. Amplitude is 1/2, period is 2 pi. And then the last one, when it's reflected, now this one's multiplied by a -2, so it's going to be, and that should be a -2 obviously, that should be reflected and like twice as tall, but reflected. And notice I add that little tail to show that it keeps on going. So this, even though it's reflected, has an amplitude of +2, period of 2 pi. And you can confirm all of those on your calculator. So that's changing the amplitude of either the sine or the cosine wave. The last thing we're going to do is change the period of the sine and cosine wave. And when we change the period, what we're going to do is add a number in front of the x. And we call that number b. And you might want to like highlight this little formula. The period of this graph is 2 pi over b. We say if b is bigger than 1, I use this very technical term that the graph is squished. And then if it's a fraction, it's stretched. Squished and stretched. So this one I'll show on the calculator as well. So I'm going to kind of clear out the ones that I've done with changing the amplitude. You could follow on your calculator as well. I'm going to type in y equals sine x, kind of the regular one, and then we're going to compare that to the y equals sine of 2x and see how those compare. So here's our sine wave, and then here's sine 2x. So what you notice is it's getting 2 of the red waves, 1, 2, in the space of 1 blue wave. 2 red waves, which is y equals sine 2x, in the space of 1 sine equals y equals sine x. Or it's what I call squished. So it's the same pattern starting at 0, 0, going up, coming down, going back to 0. But if you notice now, the tick marks have changed and they're visibly squished together. And when you write these in for yourself, you're going to visibly squish them together. The b here, people ask a lot of times, well, how do you know what the b is? The b is the number in front. So 2 pi over b, 2 pi over 2 is just pi. And just back to the tick marks for a second, how do I know what those are? You're always splitting the period into quarters. So if I'm splitting pi into quarters, it's 1 quarter, 2 quarters, 3 quarters, 4 quarters. Excuse me, and so 2 quarters, of course, is a half. If I have y equals sine 4 theta, sometimes it's helpful to do the period first. The period here is going to be pi over 2. So if I split pi over 2 into quarters, so what's 1 quarter of pi over 2? Well, doesn't of mean multiply, right? And a quarter of a half is basically an eighth. So we're going to count by eighths. So I didn't fill this one in for you. It'd be 1/8, 2/8, which is 1/4, 3/8, and 4/8. That's the hardest one we'll do. I call this one super squished, right? And we want those tick marks to be close together so we can see that it's super squished. The amplitude is still 1, by the way, period now pi over 2. That's the hardest one. The next one here, when we have b as a half, this is nice because it's going to stretch us out. 2 pi divided by a half is 4 pi. And we're going to also split 4 pi into quarters. Well, isn't a quarter of 4, isn't it just 1? So it's 1 pi, 2 pi, 3 pi, and 4 pi. And again, we take those same kind of critical points and we stretch them out. When we just change the period, you'll notice amplitude was 1 all the way across, all the way across. And of course, you could go and validate that on your calculator, right? So we had the sine 2x in there. I could add in the sine of 4x, sine 4x, and then I'll also add in the sine of 1/2 x. And then we can add those in. So there's that sine of 1/4 x, or sorry, 1/2 x. There's the sine of 1/2 x. The sine of 4x first, then the sine of 1/2 x. Can get kind of complicated there looking at them all at once. So now we just go through the same thing, but with the cosine wave, and you'll notice here that I've taken the tick marks off, that we have to start doing them for ourselves. So here, when the b is 2, 2 pi over 2 is pi, and we split that into quarters. 1/4, 2/4, 3/4, 4/4. Amplitude still stays 1, and then we follow the same pattern of the cosine wave. Cosine of 4 theta, the b is 4, so just like above, it's 2 pi over 4, which is pi over 2. We split that into quarters. 1/4 of a half is 1/8, 1/8, 2/8, 3/8, 4/8. And I know that's a lot to write all that down, but that's as squished as we'll get. Of course, amplitude is still +1. The last one, cosine of 1/2, so 2 pi over 1/2 is going to equal 4 pi. Sorry, hard to write there. 4 pi. Oh my God, 4 pi. So we're going to stretch it out, 4 pi, counting by fourths. 1/4 of 4 is 1 pi, 2 pi, 3 pi, 4 pi. And again, cosine always starts at 0, 1, because the cosine of a 0-degree angle is 1. Amplitude is +1. So after learning the main parent graphs for sine and cosine, we've either changed the number in front, the a, and that's changed the amplitude, keeping it always positive, even if it's reflected. And then the harder thing that's a little bit more tricky is to change the number in front of x, the b we call it, using our formula 2 pi over b. We either have a squished graph, and we would know those tick marks, super squished, or stretched. That's it.